Alright, good day everyone. So welcome back to my YouTube channel, and this is Kasaligan Vlogs. And today we will be talking about or tackling about integration of rational fractions using partial fractions. So let us first have the introduction. So a rational fraction is a quotient of two polynomials n of x over d of x. So fraction can be proper or improper fraction. When it is called improper fraction if the degree of polynomial in the numerator is not less than in the denominator. And such a fraction may always be reduced by division to a mixed fraction consisting of polynomial and a proper fraction. A fraction is irreducible, that is when the numerator and denominator have no common factor. So let us have an example of this one. This is a proper rational fraction, and this one is improper fraction. These are the examples. So in evaluating the integral of a proper rational fraction, it is essential to know how to represent the given fraction as a simpler fraction, and these simpler fractions are called the partial fractions. So example, this one, we will convert this one into a partial fraction. So x squared plus 9x plus 2 over x minus 1, x plus 2, and x plus 2. And we will convert 2 over x minus 1, 3 over x plus 1 plus negative 4x plus 2. So this is what we call as a partial fraction. By the use of the simpler fractions are called the partial fractions. So the theorem, so in order for us to solve how to convert or how to represent the given fraction as a sum of simpler fraction, and this simpler fraction is what we call as partial fraction, we need to have this theorem, or we need to follow this theorem listed below. So any rational fractions may be resolved into sum of partial fraction subject to classification listed below. The first case is that if a linear factor a plus bx occurs once a factor of denominator, there corresponds to this factor one partial fraction. So this one, take note of this one, this is one partial fraction where a is a constant and a should not be equal to 0. If a linear factor ax plus b occurs n times as a factor of denominator, they correspond to the factor of n partial fraction is this one, a1 ax plus b. Then we have 2, repeat here, a2 over ax plus b squared, and so on. And where a1, a2, an are constant, and it should be an should not be equal to 0. Third case is that if a quadratic factor a squared plus bx plus c occurs once a factor of the denominator, they correspond to the factor one partial fraction ax plus b, ax squared plus bx. Or it could have this one, to each non-repeated irreducible factor, there corresponds the partial fraction of the form a times 2x. This is a times 2x plus b over ax squared plus bx, where a and b are constant and to be determined by the first derivative of ax squared plus bx plus c. So this 2ax plus b is derived from the first derivative a squared plus bx plus c. And the last one case is if a quadratic factor a squared plus bx plus c occurs in n times as a factor of denominator, there corresponds to their factor in partial fractions. We have here a sub 1x bx, a sub 1x plus b1 over x squared plus bc, and so on, where a's and b's are constants, and this one is not equal to 0, equivalent to 0. Note in the statement above theorem, it is implied that the quadratic factors mentioned can not be expressed as the product of two linear fractions, so not factorable, or product of two linear factors. So there are two general methods for finding the values of the constant. The first one is by assigning a particular values to x in order to obtain equations involving at least one of the constant. And the second one is by equating the coefficients of equal powers of x to obtain simultaneous equations involving the constant. So these are the two general methods that we need to apply. So let us have problem number 1 by applying method 1 and method 2. Okay, the problem or the equation is the integral of x squared plus 9x plus 2 over x minus 1, x plus 1, and x plus 2 dx. So we have to transform this one into the sum of partial fractions. So we could have this as a over x minus 1 plus b over x plus 1 plus c over x plus 2. So we could equate this into a sum of partial fractions. Okay, the first method is by assigning. Okay, this is the first method by assigning particular values to x in order to obtain equations involving at least one of the constant. Okay, so let us have first, we will equate this one. So this one is x squared plus 9x plus 2 over x minus 1, x plus 2, x plus 2. And this one is dx is equal to the partial fraction of a over x minus 1 plus b over x plus 1 plus c over x plus 2. So we have to equate. The next step is we need to find the value for a's and a, b, and c. So multiply all this by this one, x plus 1 para x plus 1 another, x plus 2, and also we have to multiply this by x minus 1, x plus 2, x minus 1, and x plus 1, x plus 2. So this one cancel. So the remaining here is x squared plus 9x plus 2 equals, if we're going to multiply this, the remaining is a times x plus 1 and x plus 2. X plus 1, x plus 2, and multiply here. So the remaining is plus b times, this is x minus 1 and x plus 2. Okay, x minus 1 and x plus 2. And for c, we have here x minus 1 and x plus 1. Okay, next is are going to assign the value for this one. So in this case, the first case is x is equal to 1 if we're going to equate it by 0. So if we're going to equate it by 0, this would become, we will substitute the value here. So this would become, okay, 1 squared plus 9 times 1 plus 2 is equal to a times 1 plus 1, then 1 plus 2. So this is 1 squared, 1 plus 9 plus 2, that is equal to 1 plus 9, 12 is equal to, this is a, this is 2 times 3. So this is 6a. So our value for our a here is equal to 12 over 6. A is equal to 2. Okay, we have now the value for our 2. Since we need to get the value for our value for a. Next, if we have here the value for a, let's move to b. X is equal to negative 1. So negative 1 squared plus 9 times negative 1 plus 2 is equal to b times our x here is negative 1 minus 1 times negative 1 plus 2. So this is 1, negative 1 squared 1 minus plus 2 that is equal to 3 minus 9 that is equal to negative 6. And this one is negative 2 times 1. So therefore negative 2b. So our b here is negative 6 over negative 2 that is equal to 3. So this is our b. Now we have to compute for the value for our c. Our c is x is equal to negative 2. So we have here negative 2 squared plus 9 times negative 2 plus 2 is equal to c times negative 2 minus 1 and negative 2 plus 1. So we have 4 minus 18 plus 2 is equal to c times this is negative 3 and negative 1. So therefore this is 3. So this is 3c. So this is 4 plus 2 that is equal to 6 minus 18 that is equal to negative 12 is equal to 3c. So our c is equal to negative 4. So now we have now the value for our a, b, and c. So this is in a first method 1. So in method 1, we need to find for the value for our a, b, and c. Okay, let's have, this is method 1. So let's execute first method 2, how to get the value for a, b, and c before integrating this using the sum of partial fractions. Okay, so let's have this one. We have to copy this. Okay, we have to copy this side. So after this one, we have to copy. This is the method 2. In method 2, okay, method 2, so we have to copy x squared plus 9x plus 2 is equal to 8 times x plus 1, x plus 2, then plus b, x minus 1, x plus 2, plus c times x minus 1, x plus 1. Okay? X plus 2, x minus 1, x plus 1. Okay, that's correct. So, first method here is we need to expand this. So, we have to expand. So, a times, this is x squared plus 2x plus x plus 2 plus b times x squared plus 2x minus x minus 2 plus c times x squared plus x minus x minus 1. So equate, this one is 3x and this one is x and this one is 0. So a squared, ax squared plus 3ax plus 2a. Okay, 3x plus 2a plus bx squared plus bx minus 2b plus cx squared multiply minus c. So next is the second method is this one. By equating the coefficients of equal powers of x to obtain simultaneous equation involving the constant. So we will equate, okay, we'll equate this coefficient to the values of x squared. So we have here a, okay, B, and C. So A plus B plus C, and this is equivalent to x squared plus 3A plus B, then x, then plus 2A minus 2B minus C for the constant. So after which we have to equate x squared equivalent to this one is A plus B plus C. The constant of x squared is equal to 1. And for x, the constant, so 3A plus B, the constant is equal to 9 for x. And for x raised to 0 or equal to the constant, so we have here 2A minus 2B minus C is equal to 2. Next, the first thing that we're going to do is this is the first equation, the second equation, and the third equation. What I did is we have to equate this first and second equation because we have full ABC or the constant. So this is equation 1 and 3. Rather, equation 1 and 3. So A by simultaneous so that we could be able to find A, B, and C. So we need to have this one simultaneous equations involving constants. So A plus B plus C is equal to 1 and 2A minus 2B minus C is equal to 2. So plus we are going to add, this will become 3A and this will become minus B and this will become 0 is equal to 3. So now we have now equation 4. Then equation 4 paired with 2 and 4. So 3A plus B is equal to 9. 4 and 2 and 4. So 3A minus B is equal to 3. So add, this is 6A, 0, this is 12. So our A is equal to 12 over 6, is equal to 2. After which, we have the value for A, so we need to find it by using equation 2. When equation 2, when A is equal to 2. Okay, equation 2 when A is equal to 2, so 3A plus B is equal to 9. So 3 times 2 plus B is equal to 9. So 6 plus B is equal to 9. B is equal to 9 minus 6, that is B is equal to 3. So now we have the value for A, B. So by using equation 1, when A is equal to 2 and B is equal to 3, so A plus B plus C is equal to 1. So our A is 2 plus B is 3 plus C is unknown is equal to 1. So 5 plus C is equal to 1. So C is equal to 1 minus 5. So C is equal to negative 4. So now we have now the value for A, B, C the same here. A is equal to 2, B is equal to 3, and C is equal to negative 4. So we now equate this. Okay. We will now equate this one. Integral of x squared plus 9x plus 2 over x minus 1, x plus 1, and x plus 2. Great. So equal to integral of 8 over x minus 1 dx plus integral of b over x plus 1 dx plus integral of c over x plus 2 quantities dx. So we have now the value for a. So integral of 2 over x minus 1 dx plus our value for our b is 3 over x plus 1 dx, and the value for our c is negative 4 x plus 2 dx. So this one we will put the constant at the left of the integral sign to integral of dx over x minus 1 plus 3 dx over x plus 1 minus 4 integral of dx over x plus 2. So our this one is in a form of natural logarithm. So our u is here is x minus 1, our du is equal to dx. Here, our u is equal to x plus 1, our du is equal to dx. Here, our u is equal to x plus 2, and our du is equal to dx. So by integration, so we have here 2 times du over u plus 3 integral of du over u minus 4 integral of du over u. Here, by integration to ln of what is our u? X minus 1 plus 3 ln of x plus 1 minus 4 ln of x plus 2 then plus c. So this is integral of x squared plus 9x plus 2 over x minus 1, x plus 2, and x minus 1, x plus 2. So this is now the answer. So again, there are two methods. This one, by assigning particular values of x in order to obtain equations involving at least one of the constants, and by equating the coefficients of equal powers of x to obtain simultaneous equations involving the constants. So that's it for example number 1. Okay, let's proceed with example number 2. In example number 2, this is 6x squared plus 3x minus 2 and x plus 1 x squared plus x plus 2. This is in case number 2. So in case number 2, we can equate this as integral of a over x plus 1 dx plus integral of b, the derivative of this one first. This is 2x plus 1 because we need to take the derivative. This is 2x plus 1 plus c over x squared plus x plus 1. Okay, this one. So this is now, we could transform this one into sum of partial fractions. Next, if this is 6x squared by the method 2, so much better ang method 2, to 6x squared plus 3x minus 2 over x plus 1, x squared plus x plus 1 is equal to a over x plus 1, then plus b 2x plus 1, then plus c over x squared plus x plus 1. So we have to multiply both equations left and right by this one, x plus 1 and x squared plus x plus 1. Here also we have to multiply x plus 1 times x squared plus x plus 1 para matanggal. So this, the remaining here is 6x squared plus 3x minus 2 is equal to, when you multiply here, the remaining is a times x squared plus x plus 1. We're going to make use of method 2 plus multiply this. So this is b times 2x plus 1 times x plus 1 plus c times x plus 1. Okay, then expand this one. So expand. So this is ax squared plus ax plus a. So we have to expand first. So this will become 2x squared plus 2x plus x plus 1 plus cx plus c. So expand here, ax squared plus ax plus a plus 2bx squared plus 2bx 3. Okay, this is 3. So 2 plus x, so the 3bx plus b plus cx plus c. So now we are going to combine all the equations involving x squared. So a plus 2b plus 2b, then times x squared. Okay, times x squared plus involving x, we have a plus 3b plus cx, and the constant is a plus c plus b plus c. Okay, this one. So by signing or by equating the coefficients, so we have here our x squared. The value for x squared is a plus 2b is equal to 6. And our x is a plus 3b plus c is equal to 3. And our x raised to 0 is a plus b plus c is equal to negative 2. This is our equation 1, equation 2, and equation 3. Let's start first with equation 2 and 3. So 2 and 3, so a plus 3b plus c is equal to 3. And a plus b plus c is equal to negative 2. So we're going to subtract. So the resulting one, this will become cancel, and this one is cancel also. So this is 2b is equal to, change the sign of the subtrahend and proceed to addition. There's a 5. So b is equal to 5 over 2. So we have now the value for our b. So we could immediately substitute by the equation using equation 1 when b is equal to 5 over 2. So a plus 2 times 5 over 2 is equal to 6. So cancel. A is equal to 6 minus 5. The value for A is equal to 1. So 6 minus 5, the value for A is equal to 1. So if we have now the value for our B and A, so we will make use of equation 3. So we have here equation 3, A plus B plus C is equal to negative 2 when equation 3 when A is equal to 1 and B is equal to 5 halves. So A is equal to 1 plus B is equal to 5 halves plus C is equal to negative 2. So C is equal to negative 2 minus 1 minus 5 halves. We equate all to the right. So C is equal to LCD, we have 2, negative 4 minus 1 minus 5. C is equal to negative minus 2, there's 2 rather, 2, 4, and 5. So this is negative 4 minus 2 minus 5 is negative 11 over 2. So we have now the value for R, A, B, and C. So we will go back to the equation given. So this one, we will equate this. We will get this first equation and we will solve now. Okay, so equating here, integral of 6x squared plus 3x minus 2 over x plus 1 and x squared plus x plus 1, and this is dx is equal to integral of a over x plus 1 dx plus integral of b 2x plus 1 plus c over x squared plus x plus 1 dx. So the value for a is equal to 1, so therefore integral of 1 over x plus 1 dx plus the value for b is 5 halves 2x plus 1, and the value for our c is minus 11 over 2 over x squared plus x plus 1 dx. Okay, after which we have to simplify. So integral of dx over x plus 1, and we could break down this one. So plus 5 halves integral of 2x plus 1 over x squared plus x plus 1 minus 11 over 2 integral of dx over x squared plus x plus 1. Okay, we will copy this one to the next equation here, equals, copy, so integral of dx over x plus 1 plus 5 halves integral of 2x plus 1 over x squared plus x plus 1. Then minus 11 over 2 integral of dx over x squared plus x plus 1. Here, our u is in form of ln, a natural logarithm. U is equal to x plus 1. Our du is equal to dx. Here, our u is equal to x squared plus x plus 1. Our du is equal to 2x plus 1 dx. Okay, dx rather, and minus 11. And this one, is in the form of inverse trigonometric function. So therefore, we have to complete first the square in order for us to get the corresponding value for an inverse trigonometric function. So is x squared plus x by completing the square. Okay, plus 1, then plus the unknown. So this is divide 2, 1 half b squared. This is 1 half, and this is 1 half. So x plus 1 half squared plus this would become 1 plus 1 half is equal to 3/4. So our u here is x plus 1 half. Our du is equal to dx. Our a here, by the use of this one, is arctangent. Is equivalent to arctangent 1 over a inverse tangent of u over a plus c, because this is in a form of integral of dx over a squared du plus u squared. So our a is equal to square root of 3 over 2. So now let's integrate. So this one, integral of du over u plus 5 halves integral of du over u plus minus 11 over 12 over 2 rather 11 over 2, then 1 over a 1 over a, because this is in the form of this one, we can this one is being transformed here. Okay, this is in the form of this 1 over a 1 over the square root of 3 over 2, then inverse tangent of what is our u. Our u, we could have this one as 2 2x plus 1. So 2x plus 1 over 2 over our a here is the square root of 3 over 2, then plus c. Okay, so this is ln of x plus 1 plus 5 halves ln of x squared plus x plus 1 and inverse or reciprocate or reciprocal. So we have here 11 over, cancel this one, square root of 3, inverse tangent of, cancel this one, 2x plus 1 over 2, square root of 3 rather, square root of 3 plus c. So this is now the answer. Integral of 6x squared plus 3x minus 2 over x plus 1 and x squared plus x plus 1 dx is equal to ln of x plus 1 plus 5 halves ln of x squared plus x plus 1 minus 11 over the square root of 3 inverse tangent of 2x plus 1 over the square root of 3 plus c. So this is the answer for problem number 2. Let's proceed with problem number 3. Integral of 2x plus 1 over x minus 2 x minus 3 quantity squared. This is case number 3 wherein there is a repeated. Okay, case number 3. Let's go back with case number 3. In case number 3, okay, no, case number 2, that is if the linear factor ax plus, of course, and n times as a factor of the denominator, we have to repeat. Okay, repeat. Okay, so we have the equivalent here, partial fraction a is equal to a over x minus 2 plus b x minus 3 plus c over x minus 3 quantity square. So this is the equivalent sum of partial fractions. So now we have to equate this to x plus 1 over x minus 2 x minus 3 squared is equal to a over x minus 2 plus b over x minus 3 plus c over x minus 3 squared. So multiply all sides by x minus 2, x minus 3 squared, and this also multiply by x minus 2, x minus 3 quantity squared. So cancel here. So the remaining is 2x plus 1, and this will become a, when we multiply this one, so this become a x minus 3 squared plus b times multiply. The remaining is x minus 2 times x minus 3. We have still x minus 3 plus c x minus 2. Okay, so next we are going to expand. So expand this one, a times x squared minus 6x plus 9 plus b times expand x squared minus 3x minus 2x plus 6, then plus c x minus 2c. Okay, expand here. So ax squared minus 6ax plus 9a plus bx squared. This would become negative 5x. Okay, so this is negative 5bx plus 6b plus cx minus 2c. And we have to combine all the coefficients of this one. Let's start with a squared, x squared rather. So a plus b quantity squared plus 6a, negative 6a minus 5b plus c, and this is x. And for the constant, we have here plus 9a plus 6b minus 2c. So equate now, since there is no value for x squared, so let's start with x squared since we have the derived x squared here. So a plus b, so this will become 0 because no value for this one. And for x is equal to negative 6a minus 5b plus c is equal to 2. This is the value for this one, 2. And for the constant x raised to 0 is 9a plus 6b minus 2c, that's equal to 1. So this is our equation 1, equation 2, and equation 3. Okay, let's proceed first with equation 2 and 3. Because this is complete, so we can now factor. Okay, let's copy all x equation 1, 2, and 3. Our equation 1, a plus b is equal to 0. Our equation 2 is negative 6a minus 5b plus c is equal to 2. And equation 3 is 9a plus 6b minus 2c is equal to 1. So equation 1, equation 2, and equation 3. So let's start first with equation 2 and 3. So this is negative 6a minus 5b plus c, and this is 9a plus 6b minus 2c. This is our equation is equated to 2 and 1. So we will multiply this one, convert this one by 2. So now the equation, the new equation is negative 12a minus 10b. Okay, the new equation is minus 10b plus 2c is equal to 4. And the other one is 9a plus 6b minus 2c is equal to 1. So this is now the new equation. So we are going to add. So negative 12a and 9a, the result is negative 3a. And this is negative 4b, cancel, and this is 5. This is our equation 4. Okay, equation 4. So equation 4 and equation 1. 4 and 1, so let's have equation 4 and 1. So you have negative 3a minus 4b is equal to 5, and a plus b is equal to 0. We have to multiply equation 1 by 3. So equation 1 by 3, so the transform 1 is this will become negative 3a minus 4b is equal to 5, and we will transform this. So this will become 3a plus 3b is equal to 0. Okay, so this cancel. The remaining one is negative b is equal to 5. When b is equal to 5, b is equal to negative 5. So now we could have equation 1 to find for our a. So our a plus b is equal to 0. So our a b is equal to negative 5 minus 5 is equal to 0. So our a is equal to 5. Now we have the value for our b and a. So let's proceed of finding the result for our c. So let's use of equation 2. Equation 2 when b is equal to negative 5 and c is equal to c is equal to when b is equal to negative 5 and a is equal to 5. So negative 6 times 5 minus 5 times b is negative 5 plus c is equal to 2. So negative 30 plus 25 plus c is equal to 2. So it's negative 5 plus c is equal to 2. C is equal to 2 plus 5. C is equal to 7. We have now the value for R, A, B, and C. Let's go back for the first equation. So we will equate this or copy this part. Okay. Okay. Copy. Integral of wait. Integral of integral of 2x plus 1 over x minus 2 x minus 3 squared is equal to integral of 5 x minus 2, because they have now the value for our a dx minus plus integral of 5 over negative 5 x minus 3 dx plus 7 integral of 7 x minus 3 squared dx. So we have now transformed that one into the sum of partial fractions. So let's proceed. So 5 integral of dx over x minus 2 minus 5 integral of dx over x minus 3 plus 7 integral of dx over x minus 3 squared. Next, we have our u here is x minus 2. Our du is equal to dx. Our u is equal to x minus 3. Our du is equal to dx. And we will just equate this one in simpler form. So this is a 5 integral of du over u plus minus 5 integral of du over u plus 7 Okay, integrate this 7 times x minus 3 negative 2 plus 1 over negative 2 plus 1. Then plus c. So this is 5 ln of x minus 2 plus minus 5 ln of x minus 3 plus, so I minus rather 7 because it will become negative, and x minus 3 raised to negative 1 plus c. So now the full equation, integral of 2x plus 1 over x minus 2 x minus 3 squared is equal to, this is in the form of quotient. So 5 L, ln of x minus 2 and x minus 3 minus 7 over x minus 3 plus c. Okay, this is the final answer for problem number 3. Okay, try this at home. So using the sum of partial fraction, you have to solve this through uh, equations or problem. Thank you so much for listening, and this once again, Kasaligan Vlogs, and you have to submit this during our time, this problem. Thank you and God bless. Write this one, by the way, in a long band paper, and you have to in this section, in this video, you have to say something what you have learned about this topic. Thank you and God bless everyone.